This video is on normal distributions. With a continuous variable, we can represent this distribution graphically, with probabilities being given by the area underneath the curve. A normal distribution is roughly symmetrical, as the diagram shows here, about a central value which is the mean, and the curve is bell-shaped, and the majority of the measurements will be grouped around the centre value or the mean. Now, the location and shape of the curve is determined by the parameters of the distribution, which are the mean, which is right in the centre of the distribution, and the standard deviation, which is the spread of the distribution. If a random variable x has a normal distribution with a mean, and this is a symbol we use for mean in normal distribution, and standard deviation, that symbol is what we've seen before, that hasn't changed. We write it like this. So we have x, a squiggly line, n for normal distribution, and in the brackets we have the mean, and then it's actually the variance. So we have to remember that the variance is the standard deviation squared. Now there's just 3 diagrams here that show how the standard deviation and mean relate to each other on a normal distribution curve. So in this first one here, I'm just going to put a red star. We have the mean, which is right in the middle. I've just circled the mean in red. Now, our first thing we look at is a standard deviation above. So we take the mean and we add a standard deviation, which is going this way, and we minus a standard deviation from the mean, which would be that way. And that means 68% of the data actually lies between the mean minus 1 standard deviation and the mean plus 1 standard deviation. Now with the second one, it's when we add 2 standard deviations to the mean and minus 2 standard deviations from the mean, and 95% of the data lies between those 2 points. And then we also have, if we add and subtract 3 standard deviations, that 99.7% of the data lies between those 2 values. Now with these, generally once again you'll just use technology to solve. Those 3 diagrams, they'll just kind of give you an idea of how the probabilities are distributed. So on a calculator for normal distribution, you go to a calculator page, you go to your menu, 5 for probability, 5 for distributions, and then number 2, the normal CDF. What it wants you to put in this is a lower bound, an upper bound, a mean, and the standard deviation. So we've got a few examples here to show you how that works. So I will talk about the question first, then we'll go to the calculator to show how to solve it on there. So this first example, if the normal distribution has a mean of 10 and a variance of 25, find the probability of x being greater than 20. So the first thing I would do here is rewrite this part here, where it has a standard deviation. So we know the mean is 10. Now remember, this value here, the 25, is the variance. And we want standard deviation, which is the square root of that. So we can actually rewrite 25 as 5 squared, because then that 5 is our standard deviation. And we want to find the probability of x being greater than 20. So what you do now is you go to your calculator, put all those values in, and you will get your answer. And I'll show you how to do that now. So on your calculator, you just go to a calculator page, follow those steps. We go menu, 5, 5, 2. Our lower bound, now this is where we've got to be aware. So we want x is greater than 20, which means our lower bound is going to be 20. And then our upper bound, we have to put a really large number, so it almost thinks it's a bit like infinity because we want to go as far as we can. And the best way to do that is do 9 and then go to this EE button next to the A on your calculator, and then 999. And that's like your scientific notation of 9 times 10 to the power of 999, so a really big number. The next one down, we put our mean, which is 10, and then our standard deviation, which is 5. Click OK, and it will show you there that your probability is 0.02275 or 0.0228 rounded. And then on our calculator, we found that the probability of x being greater than 20 was 0.0228. Example 2. The variable x is normally distributed with a mean of 40 and a standard deviation of 10. We want to find these three things. So first of all, I'm just gonna write our notation. So our variable x, we've got a normal distribution, the mean is 40, and the standard deviation is 10. And then we're going to just calculate these different things. So once again, same steps for our calculator as before in the last example. It's just going to depend on how we put things in now. So we're going to go to the calculator and we are going to do each of these three in there. This example on our calculators for the normal distribution, we need to go to menu, once again probability, distributions. As we are going between two values, we want normal CDF. Our lower bound here is 37, our upper bound is 48, our mean was 40, and our standard deviation was 10. Just put all those values in, click OK, and there you see we get the answer we found, which was 0.406. For the second one, we still need to do a CDF, so it'll be menu, probability, distributions, and a CDF. Our lower bound this time, we want x is greater than 45, so our lower bound will be 5, but our upper bound is going to be a big massive number, so the best thing is to put 9, click the double E button here next to the A, and then just do 3 more 9s. Our mean is 40 and the standard deviation is 10. Put that in and you see you get our answer. And then the same idea for the last one when x was less than 26. So menu, probability, distributions, normal CDF. This time our lower bound will be that negative 9E999, a very, very small number. Upper bound is 26. Our mean is still 40 and our standard deviation is still 10. And there you see you got our answer of 0.081. Example 3. The times taken by students to complete a puzzle are normally distributed with a mean of 28.3 minutes and standard deviation of 3.6 minutes. Calculate the probability that a randomly selected student took at least 30 minutes to complete the puzzle. So let's do that one first. So we need to do our normal distribution. So we have our variable x, our normal distribution. Our mean is 28.3 and the standard deviation is 3.6. So we want to calculate the probability that a randomly selected student took at least 30 minutes to complete the puzzle. So we want the probability that x would be greater than or equal to 30, because at least 30 minutes, that's how we represent that. Put that information into your calculator just as we've done before, and you should get 0.318. Part B, we've been told out of 10 randomly selected students, 5 or fewer than them took at least 30 minutes to complete the puzzle. Now this is where we have to read the question, and when it tells us here out of 10 randomly selected students, that's the same idea as a number of trials. So this would actually be a binomial. Because there's 10 students, so 10 trials, the probability of success would be that it took at least 30 minutes, which is what we found in part A, so that would be 0.318. We're wanting 5 or fewer, so the probability that x is less than or equal to 5. Then we use our calculators with the binomial as we did it in the last lesson. To work that out, it would be a binomial CDF with a lower bound of 0 and an upper bound of 5. And you would get an answer of 0.938. So make sure you can do both of those on your calculator. We then have inverse normal calculations. So sometimes we are given the percentage under the curve and we need to find the value corresponding to it. So it's always good to make a sketch because we have to use the area to the left of the line we draw on our sketch when we're using our calculator. Here are your steps on your calculator to put this in. So you've got the calculator menu, probability, distributions, and then number 3, inverse normal. This first example, we have given that the normal distribution has a mean of 15 and a standard deviation of 3, or a variance of 3 squared. Determine x where the probability that x is less than x equals 0.75. So we're wanting to find out what the value of the lowercase x is. that gives a probability of 0.75. So as I said earlier, we always like to draw a sketch in these situations. So here's our normal distribution curve. Now we want the probability that it is less than 0.5 from the question. So 0.5 is obviously 75% of the way through the graph. And we want where x is less than this, so we're wanting to find out this section. That's great because this shaded area there is to the left of the x value, which is what we can do to do the inverse normal. So now I'm going to go to your calculator so I can show you how to find the x value. For inverse normal, go to add calculator, follow the steps again. So you've got menu, 5, 5, and 3 for inverse normal. Now this time I want to put the area in. So in the question the area was 0.75. Our mean was 15 and standard deviation 3. And that's all you need to put in. Click OK. And it tells us there that x value will be 17.0235 or 17.0 to 3 significant figures. Example 2 on this, we've got cartons of juice as such that their volumes are normally distributed with a mean of 150 and a standard deviation of 5 millilitres. 5% of cartons are rejected for containing too little juice. Find the minimum volume to the nearest milliliter that a carton must contain if it is to be accepted. So once again here, let's draw a little diagram. So here's our normal distribution. It's got a mean of 150 mils, so the mean goes right down the middle. Standard deviation of 5. 5% of cartons are rejected. So the rejected part is only at 5%, so it's going to be down this end. And anything underneath that is going to be rejected. We'll call that value M there that we're trying to find. So in annotation, I'm going to use V for volume. And a normal distribution, our mean is 150 and our standard deviation is 5 millilitres. Use your calculator as I showed you in the example before. Now we wanted to find the probability where the volume is going to be less than this value of M, which would be equal to 0.05 or 5%. Use your inverse normal on the calculator and then you will find that M is equal to 142. So it'd be 142 millilitres, anything less than that would be rejected. Now I haven't shown an example here, but really quickly, if you were given a question where we'd have a normal distribution and it told us that the probability was of maybe the probability of x greater than x equals 0.2 or 20%. So I want to know what value of x means that our probability of it being greater, which would be this side, is 0.2. Now what I was saying earlier is the inverse normal only calculates the percentage to the left of this value of x. So if you ever find these situations, we actually are wanting to find this purple shaded area. We need to use that in our inverse normal. So what we would do is we would change this equation to the probability of x being less than x is equal to 1 minus that probability, which would be 1 minus 0.2, which is 0.8. And then we use that probability of 0.8 in the calculator for the inverse normal. So it's just remember the probability has to be to the left of the value you're trying to find. And that is a normal distribution.